Hello, everyone. So right now we go for the 6.2, with application for the norm distributions application. Uh, so I just so we use the formula Z equal X minus mu over sigma. So for example, amount of sugar energy drink approximately normally distribution with the mean 40 grams and the standard deviation is 7 grams. So we know mu, this one of 40, uh, mu is 40. And for A, what is the probability random select energy drink will contain more than 40 grams of a sugar? So as we know, we have a formula for this. So we use these formulas up there. So we have, so this one is X is 54, and that's the sigma right here, standard deviation, that is 7. So we got Z equal 54 minus 40 over 7. So we got acids, we got this 2. So we have a 2. That is for that. So now can we go for the I can use with the calculator. So we can use with the calculator for that. So this one 54. So X is 54 right here. So this one is 54. So we know it's we have the X right here, 54. And we're looking for this area right here. So I can either one you can use the table, or we can use with the calculator. So how about we can use with the calculator, more easier. So the second, so we do the same thing with the calculator. Okay, let me bring up the calculator. So calculator's right here. Second verb. So we go with the second verb, and we go down to the number 2, normal CDF. And we know the lower, the upper. So right here, the lowest in here, we can say as 40, and the upper 9999. The mu, no, the lower is 54. Sorry for that. CDF 54, and the mu is 40, and the sigma right here is 7. So the lower 54, the upper 99999, the mu is 40, the sigma is the 7. So we can have, So this area right here, so this one right here is 0.22 something. So right here, so 0.0228, 0.0228. And for the B, we got what is the probability that a random select energy drink will contain between 30 gram and 50 gram of a sugar in the between. So right here, so this one is 30 and this one is 50. So we're looking for that areas right there. So we can still do the same thing, control, no, uh, second verb and number two, and the lower is 30. Now it's the upper 50. And we do the same mu and same sigma. So this one is, so this area right here at 0.8 and 4, I think it's 7 for 7. And we can apply for the z's in there. So we can have is the, so z equal 50 minus 40 over 7. So this one 10 over 7, approximately about 1.43. And then we do another one, it's the same thing because that's one is 5. So this one is z, we have to do both way. So z equal 30 minus 40 over 7. So this one is minus 1.43. Yeah, so we can add them up, we can subtract them together, we get this, or we can use a calculator. I think it's more calculator, it's more convenience for us, and we can easy to see it. Use a calculator more convenient than anything. So in here, another example, the length of the human pregnancy, approximate normal distributive with the mean is 270 days and the standard deviation is 15 days. So we know this one, 270. So this one approximate of 9 months, 9 months. And this one is sigma, so this one is 15. So and we have yeah, this one approximate of 9 months, so we know. And let's see, what is the probability that the random select pregnancy will be less than 250? So should be, I just should be around this area. So we're looking for this, and we know as this one is 255, and this one mu is 270, and the sigma is 15. No, 15, not 18, 15. So we do the same thing. I bring up the calculator. I hope everybody can see my calculator. So second, repeating myself again, second verb, and number two, norm, two, normal, CDF, and the lower is this one minus 999. The upper is 2.55. So minus 99999. The upper 255, and a mu in here is 270, and a sigma right here is 15. Sigma is 15. So we can go page. So we got so this area right here, 0.15. I can round up 9. And we go for the B. So this one in the between. This one 255, 255, and 290. So we can do the same thing, but this one is right here. So we're looking for this shape right here, this area right here. Okay. So we go second var, number two, normal CDF. Now it's the lowest 255, and the upper is 290. And the mu and the same thing, and the sigma is the same thing, we page. And this one is 0. So this one is 0.75, right? Yes, 0.75. And now we can go with another example. So in order to get Kali economy, you need the score with the top 6% of application taking emission test. The test score or normal distribution of the mean 700 and standard deviation 30 point. What is the minimum score required order for Kali economy? ca- um, academic, pandemic. So we can draw this one. L shape, and this one is so this one is the mu 700, and a sigma is 30, and we're looking for this area. And this one is 6%. So 0.6. So we're looking for 0.6. So yeah, so 0.6. So 6% applied administration. So so 6% right here. And basically we got 1 minus 0.6. So this one is, so this one equal 0.94. So I bring up my calculators up, and I clear second verb and go to the second number 2. So the lower so this one This one I got, so this one we should go with the inverse norm, inverse norm. So this one number 3. So I can go second var, second var, and number 3 inverse norm, inverse norm number 3, and the area. So the area is 94, the mu is 700, and the sigma is 1. So the mu is 700. No, the area 0.94, and the mu is 700, and the sigma is 30. So we can see. No, this one should be wrong. So second verb norm, and this 1.6. Okay. Yeah. They get around 7 point something. Okay, for this, we can go with, sorry for that. So, second verb, and we're looking for the area for the maximum, the score. So we can have this, and 94, and the mu is 700, and the sigma is 30. So we can go like this, and this one about approximately, approximately. So this one approximately, what are the minimum score? So we're looking for approximately about 7, 4, 3, 7. That is the score. So this is the score. So this one, that is the order for the California. We need that that much for that. Okay, so this one will be done for section 6.2.